Good morning, all. Am I audible? Please let me know in the comment section. Shall we start the session? I am expecting some responses from your side. Any response? Good morning, Kanaka Savita. Okay, fine. So we are solving. Yes, ma'am. Good morning. We are in three-phase circuits. Yesterday, I hope you might have learned something about three-phase circuits. Let's continue the lecture with that. But yesterday I had given one homework question. I don't know how many of you solved that. So may I know how many of you solved that question? If you have got the answer, just drop your answer in the comment section. Good morning. Okay, drop your answer in the comment section. Yesterday I had given one homework question, right? I hope. What is that question? A balanced delta connected load impedance value is given as 8 plus j times of 6 ohm per phase. They told that this impedance is per phase, but it is a delta connected structure, and this delta connected structure is connected with a supply voltage of 400 volt and a frequency of 50 hertz. Three-phase system. Of course, it is three-phase system only. Three-phase system supply. If the input power factor is to be improved to 0.9, what they are doing, this is the actual system. Now here, they are improving the power factor of the input to 0.9. How they are doing this? In order to improve this power factor, they are bringing capacitor bank. They told these things, right? They are bringing a capacitor bank, and this capacitor bank is going to be connected with our system. If the input power factor is to be improved to 2.9 by connecting a bank of star connected capacitor. So this capacitor bank is connected in star connection. Now the required kVAR, it means here what is the amount of kilovolt ampere reactive power demanded by the capacitor? This is the question. Basically, capacitor will be consuming leading reactive power. We all know. So this is the given question. So first step, find the existing reactive power. What is the actual reactive power and power factor offered by the circuit? See, this is the data one. Already they had given the information about the system. There is one system that is a delta connected, its correspondent impedance, and it is connected with the supply voltage, frequency, three-phase system. Everything is clearly given already. Now, from this data, what you can do, you can identify the power factor, existing power factor. Before improving the system power factor, first identify the actual power factor. What is the available power factor? How will you calculate it? Impedance is given, na? Impedance is given, and it is delta connected, and its correspondent supply voltage is given. Everything is given. So it's very easy to identify the power factor of the existing system. Can you please do it? Tell me now, what is the power factor of this existing system? First consider only data 1. Later we will be coming back to the second data. I need your help. Just to try it. What is the power factor of the existing system? Just drop your answer in the comment section. How will you do that? Impedance value is already given. Now you know how to calculate the power factor angle from impedance. It's very easy. Anyone? No. Why you people are not responding? I'm just asking what is the power factor of the existing system. See what they told. 0.8. Okay, cos pi equal to zero point 0.8. It means 36.86. That is the phase angle difference between the voltage and the current. Very good. Yes. So let me show you. Basically, how will you connect the delta connected system? So they clearly told that there is one resistance and the inductance. According to the given data, I am drawing the diagram. Okay, there is one resistance and the inductance. See, the imaginary part of the given impedance is positive. So I am assuming that positive impedance will be possible only in case of inductor. If you have capacitor, then the imaginary part of the impedance will be negative one. So it is clearly given that it is in positive. I am assuming that the given system is having inductor. Okay, so this is the given system. And what they had given so many data. The data is first, always I told you in three-phase system, the value voltage will be given what? Line to line RMS voltage only will be given in case of three-phase system. And they also given its correspondent frequency. Now, real part of the impedance per phase, don't forget per phase, is 8 ohm, they told. Imaginary part is 6 ohm. Per phase in the sense, same value will be repeated in all other branches. It will be 8, it will be J6. Actually, this is the given. This is the given data. Okay, sir, fine. This is fine. Now, how will you calculate the power factor angle? Power factor angle, in order to know the power factor angle, either you can calculate the total impedance and the total load, you can find out the total phase angle difference here, or you can see all the impedance are identical to each other, all the phase impedance are identical to each other. So values are equal. In that case, you can consider any one per phase impedance. So I am just considering phase impedance directly, and you can calculate the power factor angle of the whole system. Why? Because all are identical. So it doesn't matter whether you are reducing the circuit or you are directly calculating the power factor. Fine, sir. So the impedance is known. From here, what we can do is we can calculate the power factor angle. Pi is equal to, first let us calculate the angle. Pi is equal to tan inverse of imaginary part of the system divided by real part of the system. So from this, you will be coming up with the power factor angle, that will be 36.86 degree. So I found the value of phi here. Yes. So if you know the value of phi, it is very easy to calculate. See, first for the existing system, we have to analyze everything. Okay, sir. Fine. So from this, now you can estimate the value of cos phi, cosine of phi. What is the value? Cos pi equal to 36 point. See, cos of 36.86 will be 0.8 lagging. Why it is lagging? Because given it is inductive load, they had given the value of the imaginary part of the impedance in positive. So it clearly shows that the system is in lagging initially. Okay, sir. Now, I just wanted to know the real power consumed by this delta connected system and the reactive power consumed by the delta connected system. I need total value. How do I calculate that? If you want to know the total value, see, we know the voltage exactly. We know line voltage, but since the given system is delta connected, in delta connected system, we know line voltage will be always equal to phase voltage. We can directly take this. But current value is not known. How will I do that? See, from this what I can say is when line voltage is 400, then same line voltage will be dropped across the phase also. So I can say phase voltage also will become 400. Why, sir? Because the given system is delta connected system. Now I just wanted to know the current flow through the each phases. So I am just taking one phase, that is sufficient. I would like to calculate the phase current first. How will you calculate the phase current? See, in order to know the per phase current, according to Ohm's law, I have to write like this. I am just writing the magnitude. Per phase voltage upon per phase impedance. Since we are in delta connected system, so line voltage and phase voltage both are equal divided by, I am just considering the magnitude. I am repeating again. I just wanted to know the magnitude. So impedance, how will you calculate the magnitude of the impedance? What it was given, the per phase impedance value is given as 8 plus j times of 6. How will you calculate its magnitude? Magnitude will be square root of real part of the impedance square plus imaginary part of the impedance square. How will you reduce it further? Numerator we are having 400 upon denominator square root of 8's power, that will be 64 plus 36. It will be 100. Square root of 100 will be 10. So from this what we can do is 400 divided by 10 will give you 40 ampere. Yes or no? So we have calculated the value of the current successfully. The value of the per phase current became 40 ampere. Okay, sir. If you know the per phase current, is it possible to calculate the total power and total real power and total reactive power directly? Of course, it is possible. Since the given circuit is having same impedance in all branches. So you no need to analyze the remaining branches. Why? Because we have already found that the current consumed by per phase is 40 ampere. So same current will be flowing through the remaining other branches also. We know magnitude of the current will be same always in case of a balanced system. If the system is balanced, then frequency and magnitude of the system is remains same. It may be a voltage or it may be a current. It value will be remain same in all phases. Then which will be different? Only phase angle. In three-phase system, if you are having a balanced system, in case of the balanced system, phase to phase angle only will be differ. Frequency and the magnitude of the voltage and the current will be remain same. So now we found the per phase current. If you want to know the value of line current, it is very easy. In delta connected system, we know line current equal to root 3 times of phase current. So it is not that much difficult to calculate. So you can directly put root 3 times of 40. That will give you the value of line current. So that is current coming from the source. This is the, so here 40 into square root of 3 times of current is going inside the network. And per phase current will become 40 ampere only. So we found everything. Yes, sir. We are having line current, line voltage, see line voltage, and we are also having power factor. Is it easy to calculate the value of real power consumed by the network and reactive power consumed by the network? Of course, it is very easy now. See, how do I do that, sir? Let me teach you. So there are two ways. Either you can go with the apparent power, or you can go with the what I can say impedance, voltage, current at all. See, let me teach you the first one. Let us go ahead with the apparent power. What is the formula to calculate the apparent power? If your system is single phase, then the formula is per phase voltage into conjugate of the per phase current. If your system is single phase. Suppose if your system is three phase, this is for single phase system. We have already gone through this. But when we are entering into three phase system, this formula will become. So this is for single phase. So in case of three phase, there are two ways to write this expression. One is, if I am writing it in terms of phase voltage and phase current, this can be written as 3 times of phase voltage and phase current. But conjugate is mandatory. You can also write this in terms of root 3 times of line voltage into line current into power factor at an angle of phase angle, conjugation of phase angle. Okay, sir. Everything is fine now. Now, what we are going to do? We are trying to estimate the value of apparent power here. Okay. So, if you want to derive the real and the reactive power from the apparent power, then it is very important to know the phase angle offered by the current also. How will you know the phase angle? Sir, I know the magnitude of the phase current. How do I find out the phase angle? That is very easy. You know already this current can be expressed. The per phase current in rectangular domain can be written in the form of 400 upon 8 plus j times of 6. From here only we have calculated the magnitude of the current. Now, how will you calculate the phase angle offered by the current? If you want to know the phase angle from here, it is very easy. The total phase angle offered by the system, let me name it as theta. How will you do? Phase angle offered by the numerator minus phase angle offered by the denominator. That is the generalized formula to know the phase angle of the total system. So numerator, if you observe the numerator, how will you calculate? Let us see. As usual, same formula, tan inverse of imaginary part of the numerator. See, if you observe the numerator, voltage is purely real component. So imaginary is 0 divided by real part minus tan inverse of. When you are bringing denominator phase angle to the numerator, this minus will appear. Imaginary part is 6 divided by real part is 8. So this is the total phase angle offered by the system. You can also keep pi because I am using pi only. Nothing is wrong. So pi is equal to, see, first part, tan inverse of 0 by 400 will be 0 once again. Tan inverse of 0 will become 0 minus tan inverse of 6 by 8 will be equal to 36.86 degree. So the current in polar form, the per phase current can be written as magnitude of the current is 40 ampere at an angle of minus 36.86 degree ampere. See, why we are getting minus? Can you observe this? Since we are having lagging system, when your system is lagging, it means what? Current is lagging from the voltage. That's why we are getting negative angle for the current. So it clearly indicates that the current is lagging from the voltage at an angle of 36.86 degree. Okay, sir. Now come back to the system. Now, how do I calculate the value of this three-phase system? Let me go with per phase. So now, sorry, three-phase power in terms of per phase voltage and per phase current component. So 3 times of per phase voltage, it will be equal to 400. I told you line voltage and phase voltage both are equal in delta connected system. Current component can be written as same 40 at an angle of minus 36.86. But it is very important to take the conjugate also. When the moment you are trying to take the conjugate, this sign will change. Then what will happen immediately? You know 3 times of 4 will be 12. So I can write 1200 into, since it is into 400, now you can keep plus 36.86. It is in polar form. Still it is in polar form. Let us continue with this. You know 12 times of 4 will become 48. So 48 and we are having 40. It is very huge 4, right? So let us continue at an angle of 36.86. Okay, sir. So this is three-phase system. Exactly. So there will be no issues till now. And you can carry on with the same data. So what should I do, sir? Now, what you can do is from here, how will you convert this from polar form to rectangular form? If you want to convert this from polar to rectangular form, then this three-phase apparent power can be written as, for I'm writing like this, 480 kilovolt ampere. It is magnitude. I'm raising it e power j. Okay, first, yes, I'm writing it in the same way, 36.86 degree. Now you know how to convert this value. So this can be further written as 480 kilovolt ampere, right? So I'm writing like this, 480 into e power j cos, 36.86 can be written as cos of 36.86 plus j times sine of 36.86. And it is in kilovolt ampere. Fine, sir. Let us further continue. 480 into cos 36.86 will give you 0.8. Sin 36.86 will give you 0.6. So this can be further written as, if I will expand the bracket, it will become 480 into 0.8 plus j times of same. 480 is common for both, right? So it will be multiplied by both of these people. Kilo, volt, ampere. Fine, sir. Now what is our next task? Finally, if you observe, I brought the answer. If you observe, if I will put 480 into 0.8, I am getting 384. So I can say the real power consumed by the system is 384. See, it is in kilovolt ampere, right? Now what it will happen? When we are considering total apparent power, it will become kilovolt ampere. Of course, right? Let me reduce this first. Similarly, if I will put 480, if I am multiplying it with the 0.6, you will be coming up with the 288. So we have calculated total real and reactive power, right? So it is in the form of apparent power, so its unit will become kilovolt ampere. Now when we are taking the real part outside, so from this I can write real part of the system will become 384 kilowatt. Similarly, unit will change because it is the unit of apparent power. Unit of real power is watt. Similarly, unit of reactive power. Now we can write 288 kilovolt ampere reactive. Yes, successfully we found the real and reactive power supplied by the source to the given balanced load. This is the initial power. Now if you observe, I told you we can also calculate the same thing with the help of individual impedances. See, when we are writing the real power, total real power directly, what is the formula? 3 times of V phase, I phase into cos pi, or root 3 times of VL, IL cos pi. Both will give you same answer only. Now here let me prove it. 3 times of per phase voltage is 400 into per phase current is 40 ampere into power factor angle we have calculated 0.8. If you multiply these three value, you will come up with once again same 384 kilowatt only. Either you can calculate it in terms of phase, or if you are calculating it in terms of line parameter, root 3 times of phase voltage and the line voltage are same. You can go with what? Phase voltage and line voltage are same. But how will you write the delta connected line current? Line current will be root 3 times of phase current, so it will be root 3 times of 40 into 0.8. Observe the network carefully. The product of root 3 and root 3 will give you once again 3. So same relation is coming again or not? So you will come up with the once again same 384 kilowatt only. Similarly, you can also estimate the value of reactive power in the direct formula 3 times of per phase voltage into per phase current into sine of power factor angle. Or you can also estimate the same value in terms of root 3 times of line voltage into line current into sine of power factor angle. So now here if you observe, same formula will become 3 times of per phase voltage and line voltage both are same in delta connected system. Per phase current is 40 ampere. Power factor angle, sine of power factor angle is 0.6. This can also be written as root 3 times of line voltage and phase voltage both are same in delta connected system, but line current is 40 times of root 3 into 0.6. So both will give you the same answer only. Once again, it will be turned back to 288 kilovolt ampere reactive power only. So this is the total exact reactive power consumed by the given network. So either you can calculate it through this formula, direct formula, or you can drop these values from the apparent power. Choice is up to you. It is completely up to you. Okay, sir. Now, is there any other formula to calculate? See, let me prove it. Come back to the network. If you observe, the resistance offered by the per phase is 8 ohm. Yes or no? Now, the real power consumed by per phase. I would like to calculate the real power consumed by per phase, or only that 8 ohm resistor. I am just focusing into it. How will you calculate? This can be calculated with the help of I square R or V square by R. But remember, it is per phase quantities because I am individually focusing only this 8 ohm resistor. What will you calculate? What will you obtain? We know both phase current and line voltage. If I am going up with the current expression can be written as per phase current is 40 ampere, so it can be written as 40 square into 8. What will you obtain? 4 square, it will be 1600 into 8. Yes or no? You can also write it in terms of voltage. If I will write it, voltage will become what? 400 voltage, so it will be 400 square upon 8. So what will you obtain? 1600 into, if I will put 8, you will be coming up with a 12800. Or if I will write 400 square by 8, 1 minute. What is the per phase current value here? The per phase current value is 40 ampere, no? Yes. So the per phase current value is 40 ampere. Mm, yes. So either you can go up with the per phase current into per phase resistance. Per phase resistance is 8 ohm, or you can go up with the what? Per phase voltage. Per phase voltage divided by per phase resistance. See here I did a small mistake. Actually, this 400 voltage is common for both resistor and the inductive reactance. You cannot directly take this 400 voltage, apply voltage division rule, find out the voltage drop across the resistor. How will you find out this? We know the total voltage, right? So voltage division rule, total supply voltage into voltage drop across the resistor divided by magnitude of the total impedance. I'm just considering magnitude of the voltage drop across the resistor. In the denominator, I must consider the total impedance magnitude. What is the magnitude of 8 plus j6? We know it will be 10. Magnitude means 8 square plus 6 square under root. It will be 100 square root, it will become 10. So I can keep 10 directly. So if we cancel it, it will become 40 into 8. So in the numerator, I have to keep 40 into 8 whole square divided by 8. It will be turns back to, see, I can write like this. Out of 2 8 square, in the denominator 1 8 is there, numerator 8 square is there, 1 8 will be cancelled, so it will become 40 square into 8. You will be turns back with the 1800. This is the real power consumed by per phase resistance. So what we are obtaining here, we are getting 18000, sorry, 12800. If you multiply it by 3 to obtain the three phase power. So let me write down the total real power consumed by the circuit. That will become what? 3 times of 12800 will be giving you 38400. Yes or no? So it doesn't matter how the way you are trying to calculate the power consumed by the network. In all the way, you will be coming up with the same answer only. Your answer will not be differ. Understand? Where is the answer? Where is our real power? I think I did mistake somewhere here, right? Why I am getting 40? Guys, listen. This is 40 only, right? Why I put 400 here? 10, reduce 10. Now we are, it will be 48 only. I'm sorry. Then it will become 38.4, 28.8 kilowatt in terms of kilowatt. 38.4, 28.8. Good. 38.4, 28.8. I made a small calculation mistake. Now we are coming up with the same answer. Na? So here initially I was trying to calculate the real power, reactive power with the help of what? Source apparent power. Directly I have calculated. Second time what I was doing, I am trying to estimate the individual power consumed by the loads. No, anyway, all the phases are having same resistor. So total real power consumed by the load equal to total real power supplied by the source. That's why we are telling that energy cannot be created at the same time it cannot be destroyed. It will be transformed from one domain to another domain. So here the energy transferred by the source, the power transferred by the source will be equal to power transferred by the power consumed by the load. Both are same or not? In the same way, I am requesting you to check the reactive power also. Why I am doing all these things such that you will get the multi-dimension. So there are so many things to understand in a single question. So it will be helpful for you to solve so many questions, variety of questions, right? Okay, so finally we have understand everything, but still we haven't completed this question. For your understanding, I have done all type of all type of dimension view. Okay, let us go ahead with the question now. So anyway, what is the question? The question is little bit different. Let us focus into the question now. But we found the total real power and reactive power consumed by the network before connecting the star connected capacitor bank. Now let us go ahead with the second question. The second part of the system is what they are doing is they are bringing a star connected capacitor bank. They told clearly in the question, a star connected capacitor bank. So now because of this, now let us estimate. See, power factor volt, I'm calling it as power factor volt. Initially we are having power factor is 0.8. Now what they are doing is because of this capacitor power bank, the new power factor offered by the circuit will be achieving 0.9. So power factor value is improved by 0.1. Yes or no? Yes, zero point 0.1 value is increased. That's why it is going from zero point 0.8 to 0.9 now. This is new value. Now the question is, under this situation, what will be the reactive power supplied by this source such that the power factor will be improved? What is the reactive power offered by the capacitor bank? Okay, sir. Let us say, first of all, we know already existing power factor, we know already existing real power, we know. What is the existing real power? 38.4 kilowatt. 38 point kilowatt. Similarly, we also know the existing reactive power. What is the existing reactive power? Existing reactive power is 28.8 kilovolt ampere reactive. So we know the existing real power and reactive power. Now I'm just asking you what type of load that we are connecting here. So it is star connected capacitor bank. It is clearly mentioned in your question. They are bringing star connected capacitor bank. Now tell me whether your capacitor will consume real power or not. They told it is star connected capacitor bank. I had a doubt immediately. In the capacitor real power consume pannuma pannada. Real power P delivery or consume whatever. I'm just talking. Is there any relation between real power and capacitor? No, sir. Capacitor will be responsible only for reactive power. So when the moment you are connecting, yeah, you can when the moment you are trying to do the changes in our system with the help of capacitor power bank, this capacitor power bank, it does not touch the property of real power. So same real power will be again reflected after improving the power factor also. Why? Because we are trying to change the system power factor with the help of capacitor bank. Capacitor bank will not touch the real power. It will be dealing only with the reactive power. Now the question is, what is the new reactive power? See, we know new power factor, we know new power, real power, because new real power and old real power both will be remain same. This beautiful things phenomena is happening because of this imaginary part of the capacitor. They never touch the real part, they never change the real part of the system. So now I'm just asking you, just by using this new power and a new power factor, can you calculate the reactive power? Is it possible? Yes, it is possible. How, sir? How it is possible? Let me prove you. Listen, what is the formula to calculate the apparent power? We know it can be calculated with the help of V into I conjugate. Of course, I'm agree with that. How will you calculate the power? Power can be written as VI, real power, VI into cos pi. I'm agree with that. So now when we are considering only magnitude, I just wanted to know the magnitude of the apparent power. If I am considering only magnitude, then this conjugate does not matter. Because when we are considering magnitude of the system, it doesn't matter whether you are taking the conjugate or not. We can directly take the value of voltage and the current. So I can consider simply V and I when the moment I am considering only magnitude. I am reminding you. So what I can do is, in place of this V and I, you can consider the apparent power because I'm just considering the magnitude. So this can be replaced by P equal to S into cos pi. This is the alternative way of writing the real power and reactive power. Also, you can write it in the same way, apparent power into sin pi. This is alternative way to calculate the real power and reactive power. Now, if I will take the ratio between real and reactive power, let's see what will happen. S into cos pi, just focus, S into cos pi divided by S into sin pi. Can I write like this? Yes. S getting cancelled. Take reciprocal such that you will get the tan format. Q by P can be written as Sin phi by cos phi, you all know sin phi by cos phi is the famous one. It can be replaced by tan phi. So reactive power upon real power can be written as simply tan phi. Or I can say from this, reactive power can be directly calculated from real power into tan phi. Did you understand? Yes, sir. So this is very important. If you remember this, see, no need to memorize. Even I too know, never keep these things in my mind. But I know how to derive it. Just understand how to bring the relation between real reactive power and apparent power. Okay, fine, sir. Keep smile in your face because we are learning something new. Maybe some of you may know these things. Fine, sir. So now, if you know the real power and power factor, now tell me. For I brought everything. Now, if you know the power, real power and power factor, can you calculate the reactive power or not? Sir, it is very simple now. How do I do that? I know. I just wanted to know the value of tan phi. But given it is power factor means this can be written as cos pi. Yes or no? Cos pi is equal to 0.9. From this, the value of phi is equal to cos inverse of 0.9. So from this, I can calculate the new power factor angle. If you take the cos inverse for this 0.9, you'll be coming up with 25.841. Yes, sir. This is the value of phi. So from this, if you estimate the value of tan of this angle, if I am taking tan of 25.841, you'll be coming up with 0.484. 4843, you can write like this. Okay, sir. Now from this, come back to the final conclusion. The reactive power supplied by total new reactive power, I'm not talking about the capacitor alone. After connecting the capacitor, what is the total reactive power changes in the entire network? Entire network means what? We are having this star connected bank now. It is connected with what? Already existing delta connected system. See, existing delta connected system is having some type of load. With this, we are bringing the star connected capacitive load. So the total reactive power, the total combination, total reactive power offered by this capacitor bank plus that star connected load, sorry, delta connected load only we are calculating now. So the total new reactive power become total new real power into tan phi. Tan phi I am getting 0.4843. We know the real power already 38.4 kilowatt. 38.4 kilowatt means 10 power 3. You can write it now because I need this value. So this will be 0.4843. So now if you multiply it by 38.4, you will be coming up with the 185918.597 kilovolt ampere reactive power. This is the new reactive power. Now we have estimated the old reactive power. We have also estimated the total new reactive power. Now it is very important. See, old reactive power is 28.8 kilovolt ampere reactive power. Now new one is 18.597 kilovolt ampere reactive power. Let us combine these things together. See, the old reactive power, let me write it together here. It will be 28.8 kilovolt ampere reactive power. Now tell me whether it is lagging or not. Yes, sir, it is lagging. Immediately you have to say it is lagging, sir. How? Because initially our system was connected with the resistor and the inductor. Which are no? Yes, sir. Now the new reactive power, if you observe, the new total reactive power will be coming up with the 18.597, 18.597 kilovolt ampere reactive power. Still it is lagging only. Why it is lagging, sir? See, we have connected the capacitor. Because of that capacitor bank, power factor just improved 0.1. It means reactive power consumed by the network is decreasing. When the moment the reactive power consumed by the network is decreasing, automatically power factor offered by the circuit will be increasing. Understand this point. Actually, power factor வந்து நமக்கு எப்போ வந்து 1 வரும் நீங்களே assume பண்ணி பாருங்க. Power factor will become 1 when the total imaginary part of the circuit will be equal to 0. Conclusion என்ன? Total imaginary part means இந்த imaginary part அப்படிங்கிறது reactive power தான். அப்ப reactive power ஓட வேல்யூ வந்து டிக்ரீஸ் ஆக பவர் ஃபேக்டரோட வேல்யூ வந்து 1க்கு க்ளோஸா போகும் அப்படிங்கிறது தான் கன்க்ளூஷன். Initially, reactive power consumed by the network வந்து 28.8 kilovolt ampere reactive power. அந்த டைம்ல நம்ம பவர் ஃபேக்டர் வந்து கால்குலேட் பண்ணப்ப நமக்கு வேல்யூ என்ன கிடைச்சதுன்னா 0.8. When the moment I was trying to reduce the reactive power with the help of the capacitor bank, let me tell you, you know, the reactive power absorbed by the inductor and the reactive power absorbed by the capacitor will be opposite to each other. If the inductive reactive power will be represented by plus, then capacitive reactive power will be represented by minus. If I will club them together, இதை நீங்க டைரக்டா ஆட் பண்ணீங்க அப்படின்னா it can be written like this: QL minus QC. I am not taking any differentiation here. You have to understand. I am not taking any differentiation. By nature, its signs are what? Plus and minus. Like if I am asking you to add plus 2 minus 1, what will you do? Plus 2 minus 1 அப்படிங்கிற 2 numbers இருக்கு. அது ரெண்டுத்தையும் ஆட் பண்ண சொன்னா you will be telling sir answer is 1. Are you taking difference here? No, I am adding, but one is in negative value, another one is in positive domain. So like that, these two people will always oppose each other. Already we have calculated inductive reactive power. When the moment you are trying to inject the capacitive reactive power, see, these two people will be opposite to each other, nature. So since it is in positive value, capacitor reactive power will be negative. So negative and positive will be added such that resultant value will be reduced to 18.597 kilovolt ampere reactive power. அப்ப ஆல்ரெடி எக்ஸிஸ்ட் ஆயிருந்த ரியாக்டிவ் பவர் கூட நீங்க என்ன பண்ணிருக்கீங்கன்னா இது வந்து இண்டக்டரோடது, இது வந்து பாசிட்டிவ்ல இருக்கு. இது கூட நம்ம என்ன பண்ணிருக்கோம் அப்படின்னா கெப்பாசிட்டரோட ரியாக்டிவ் பவரை கொண்டு வந்திருக்கோம். இதனால என்ன இருக்கு அப்படின்னா நியூ ரியாக்டிவ் பவரோட வேல்யூ வந்து 18.597 கிலோவோல்ட் ஆம்பியர் ரியாக்டிவ் பவரா ரெடியூஸ் ஆயிருக்கு. எக்ஸிஸ்ட் ஆயிருந்த வேல்யூ எவ்வளவு? ஓல்டு ரியாக்டிவ் பவர் வந்து 28.8. அப்படியே அதை ரெடியூஸ் பண்ணுங்க. அப்ப இதுல இருந்து கெப்பாசிட்டரோட ரியாக்டிவ் பவர் மட்டும் எவ்வளவு ஆட் ஆயிருக்குன்னு பார்க்கலாமா? So minus QC equal to 18.597 minus 28.8. So 18.597 minus 28,800 போட்டீங்க அப்படின்னா you will be coming up with the value of reactive power QC. Anyway, both sides we are having minus. It will be minus 10.202 kilovolt ampere reactive power. Minus minus will be cancelling each other. This is the reactive power supplied by the capacitor bank. Because of this, net inductive reactive power value is reduced. When the reactive power value is reduced, automatically power factor value increase. Already they told that power factor is increased to 0.9. See how beautiful this question is. We have learned, sorry, we learn a lot. I know that. So I hope that, right? So yes, so finally what we have understand, this new capacitor bank value, everything is calculated. The question is this one only, na? The resultant answer is 10.202 kilovolt ampere reactive power is the reactive power consumed by the capacitor. You got it? I hope you all have understand what I am trying to conclude from here. Chalo sir. Now just recollect it, whatever I have told you. So it is very important to understand the circuit in a proper way. How we are calculating real power, how we are calculating reactive power. When we had capacitor reactive power with inductive reactive power, what will happen? I told now, exam is always very easy, but it is very important to be crystal clear with the basic fundamental. You should be very confident. This is plus, this is minus. It should be like that only, sir. It is chota basics only, but it is very important to remember. Fine, sir. Now, what can we do now? Let me drop the next question. Let's see what you people will do. At least you have to understand this now. Let me drop the circuit, try to bring the answer. There is one delta connected system and a star connected system, both. First, let me drop the delta connected system. There is one delta connected system. This delta connected system is having, yeah, completely pure inductor. They told this. We have drawn. Okay. Next, inbuilt. What they did is, inside this delta connected, they are bringing one star connection. Yes, it is connected like this. This is the given network. Now they told that all these inductors are having same value, all the capacitors are having same value. Let me read the question. In the balanced three-phase system, it is having the frequency of 50 Hz. Circuit shown below. The value of the inductance L is equal to 10 millihenry. The value of the capacitor C is required for which all the line current are 0. Find the value of the capacitor for which all the line current of the above system is approaching into 0 ampere. That is the given data. That's all. They have given the this network. Then they told they had given the value of inductance. Now they are asking you to find out the value of capacitor C such that the value of the all line current. Line means what? This is your line currents. All the line currents will be approaching to 0 ampere. That's all. That is the question. Proceed now. Take your time, 3 to 4 minutes also, but try to bring the answer by your own. Okay? Understand the circuit. ஜஸ்ட் ஃபோக்கஸ் பண்ணுங்க. ஐ மீன் இது தெரியும் தெரியாது அதெல்லாம் யோசிக்க கூடாது. ஒரு கொஸ்டினை சால்வ் பண்ணும்போது என்ன கேட்டிருக்காங்க, லைன் கரண்ட் வந்து ஜீரோ ஆகணும். கரண்ட் ஜீரோ ஆகணும் அப்படின்னா இம்பிடன்ஸ் எப்படி இருக்கணும், அப்ப இம்பிடன்ஸை வந்து எப்படி மாத்துறது, இது எப்படி கொண்டு வர்றது இந்த நெட்வொர்க்ல, அந்த மாதிரி யோசிங்க. Do it fast. It is very simple question. Don't think too much. You will coming up with the answer in 4 steps. Anyone got the answer? Instead of putting அப்படின்னா just drop it in the comment section, right? Because I'm waiting for your answer only. So it is very important to drop your answer in the comment section. Face serious வச்சுக்காதீங்க. Just keep smile and try your best. There is nothing serious here. Just you people are learning. the answer? Chalo. Listen, let me try to bring the answer for this question. Actually, what they told, they had given some clue. The clue is, sir, the line current will become 0 ampere. They clearly told all the line current will become 0 ampere. Okay. So I'm just asking you, forget about the star and delta connection and at all. Suppose I'm having two branches like this. Okay, two branches like this, and they are interconnected at a junction. Now, I don't know, suppose let me have some value here. Let me have. Let us take impedance or admittance. Consider impedance or admittance. You know, both are reciprocal to each other. That's all. If I am considering Rajesh 30 millifarad, very good. Let's see. I don't know. Let us check. So is that or Y? Now I am putting there are two current. I am calling this current is IY and I am keeping this current is IX. I told that this IX value will become 0 ampere. Now what will you say? Sir, if Ix is 0, definitely you will say that, sir, this branch and this branch both are connected in series. When the value of Ix will become 0, Iy also will become 0 ampere, sir. Yes or no? This Iy also will be 0. And this Iy will be 0 only when there are two possibilities. Now I am just asking. Now determine the value of the impedance for which the value of Iy will become 0. That is the question. Yes or no? Just to determine the value of impedance for which the value of Iy will become 0. You know, according to Ohm's law, Iy can be written as Iy is the current flow through the impedance. It can be written as voltage drop across the impedance divided by the value of the impedance. So here the conclusion is you cannot make the value of voltage as 0 because this voltage is this circuit will be driven by voltage source. Source value you cannot change, generator value you cannot change, but load parameter only will be keep on changing. Yes or no? So here what will happen is this current will become 0. It will be possible, sir. Only this impedance will be approaching to infinity. Yes or no? This is correct. Suppose if you are writing it in terms of admittance, V into, 1 by Z can be replaced by admittance. Now tell me, if you want to make the value of current as 0, you cannot touch voltage, but you can make the value of admittance as 0. If I make the value of admittance as 0, 0 into value of the voltage will become 0. So the resultant current will become 0. So what I have understand here, the current flow through the circuit will become 0 means either impedance offered by the network is approaching to infinity or admittance offered by the network is approaching to 0. That's why that current is approaching to 0. You got it now? First this conclusion. Now let me increase. Suppose if I am increasing, now let me keep two branches. For your understanding, let me keep two branches. Same network. Now these two branches are having some different value. Let me call it as Z1 and I am calling it as Z2. But do remember, I told you always if you are going up with a parallel network, if you want to obtain the answer easily, then go ahead with the admittance value. Okay, calculation will become very simple. I2 and I3. I2 and I3. Now they clearly told that the value of, now I am giving the clue. I1 will become 0 ampere. Determine the value of the net admittance. Okay, net admittance or net impedance, whatever it is, such that the value of the current coming to this network will become 0. I1 will be 0 means there are two cases. You can see if I1 will be 0 means if you apply KCL at this junction, how will you write this? You can write incoming current is I1, outgoing currents are I2 plus I3. Can I say like this? Yes. So from this, when I1 will be 0, I can write 0 equal to I2 plus I3. Yes or no? So from this, if I will derive it further, it can be written as I2 equal to minus I3. What is the conclusion from here you have understand? See, this current, right? When the line current will be 0, it means either the current flow through these two branches opposing each other. See there, this minus indicates the value of I2 and I3 are equal to each other, but they are opposing. Magnitude of the two currents are equal, but sign is opposite to each other. Sign is opposite. Magnitude is equal, but sign is opposite to each other. That's why when we add, see, now there are two branches. One branch is consuming 10 ampere, another branch is consuming minus 10 ampere. It means what? The resultant current, if you apply KCL here, see, sir, when I am adding these two, 10 ampere minus 10 ampere will be heals to 0 ampere or not? So that's it is become 0 ampere. So line current approaching 0 in the sense the current consumed by these two parallel branches are opposing each other with the equal magnitude. We can say alternative way. We can also write this in the alternative way in terms of current. Suppose if you are writing it in terms of impedance, it is very simple. So see, let me write it. We will derive from here. So we got the conclusion that I2 and I3 are opposing each other. I am just observing the basics. Now from this I can write it in terms of impedance. Current flow through the first branch. Current flow through the impedance Z1. How will you write? See, the two branches are connected in parallel. Z1 and Z2 both are connected in parallel. So voltage will be remain same in parallel circuit. Can I write like this? Current can be written as V by Z1 equal to minus V by Z2. Can I write like this? So V will be cancelled out. So I'm just considering magnitude now. Magnitude means you can neglect this sign. Okay, we found that both are opposing each other. So I'm just considering magnitude now. So now finally what we have understood, 1 by Z1 equal to 1 by Z2. I'm considering only magnitude. Do remember. So the conclusion is, from this what I can say is, if these two impedance, or if you want to consider the sign also you can consider, nothing will be wrong. I just wanted to show that these two people are opposing but their impedance will become equal. Or admittance, either you can write it, see, from this if you write the admittance, how will you write? 1 by Z1 can be written as Y1, 1 by Z2 can be written as Y2. See there, from this these two currents are equal but they are opposing each other. So what we have derived, this 1 by Z1 equal to 1 by Z2 can be further written as, if you do the cross multiplication, then it can be written as Z2 equal to minus Z1. So once again, impedance of those two branches are equal but they are opposing each other. Admittance of those two branches are equal but they are opposing each other. So from this we have derived these many informations. So the current zero in the sense, either the current flow, not either, this is the truth case. So the line current will become zero in the sense, whenever two people are connected in parallel, if the net current consumed by them will become zero in the sense, the current consumed by those two parallel branches are opposing each other, or admittance of those two branches are opposing each other, or impedance of those two branches are opposing each other. Because of that only, net resultant current will be approaching to zero. Conclusion we got. Now come back to your circuit. See, there is one delta connected network under one star connected network. What I am willing to do is, I just wanted to convert this star connected capacitor into delta connection, because one is in star, another one is in delta. It is too difficult to reduce the network now. Tell me, when three branches are having equal value in case of star connection, when you are converting into delta, how will you calculate the resultant value? I have already told you, when we are going from star connection, delta connection, what will happen? Let me call C1. Okay, C dash, not C1, C dash, because all are same value now, equal branches. How will you calculate the delta connected delta capacitor? It is very easy. C dash will be equal to, if I am naming it as A, it will also be A. I am just considering only one branch. So when I am considering B, and this will also become B, this will be C, then this will be C. Now suppose if you are trying to calculate the C dash between A and C, how will you write down this expression? Here in place of in the branch of A I am having C, in the branch of C also I am having capacitor C, then product of those two value divided by new branch, the branch that we are not considering, that is also C only. So if you reduce this capacitor value, you will be coming up with the what? Reduce this C square, C square, C square. So total it will become 3 times of C square by C. 1 minute. So the value of C dash will become 3 times of C. So what I have understood is C dash will be 3 times of C, 3 times of C, 3 times of C. Now draw this network. I am transforming this network from star to delta. The new network will be like this. Sorry, I don't have space here. What can we do? Let me drop here. So the new network will be coming up with a one inductor and a capacitor. Both are will be in delta only. Okay, and they will be connected at the same junction. Similarly, if you observe, let me expand this for your understanding. First, let me draw the inductor and the capacitor. Both are connected like this. Again, if we extend this line further, again this capacitor will be like this. They will be attaching like this, and just expand this line. Oh, sorry, 1 minute, 1 minute. So now if we expand this delta connection, inductor, see all are connected together only, nothing is wrong. So this is how your resultant circuit will be looking like. If you understand, see this is 3 times of C, new value will become 3 times of C, it will be 3 times of, see this is inductance L and this is L. Now it is time to calculate the reactance. We are in AC analysis. I told you, you cannot go up with the inductor and the capacitor. It is very important to convert it into inductive reactance. So L will be transformed into J omega L. L will be transformed into J omega L. Similarly, how will you write the capacitor? It can be replaced by 1 by 3 times of J omega C. Why 3 is coming? You know the reason. 3 times of capacitor. So 1 by 3 times of J omega C. Here also capacitor will be replaced by 1 by 3 times of J omega C. Now see that these two branches are connected in parallel, these two branches are connected in parallel, these two branches are connected in parallel only. Consider any one phase, any one phase. Let me tell you, when this current is approaching to zero, what is the actual conclusion? This could be possible, as I already told you that, then it should be possible only when these, see these two people are connected in parallel, inductor and capacitor are connected in parallel. Similarly here also inductor and capacitors are connected in parallel. These two people are connected in parallel. I have already told you it could be possible only when those two impedances are opposing each other with equal magnitude. Okay, now let me write. You can consider, suppose in place of inductance Z1, I am considering capacitive reactance 1 by J omega C. Okay, and in place of C, if you want to write down only magnitude, you can write. Let me calculate the overall impedance for your understanding. Let me write Z1 equal to, let us assume 1 by J 3 times of omega C, and the impedance Z2, impedance offered by the inductor branch, it will be J times of omega L. Yes or no? And I told you these two magnitudes will be approaching equal to each other. I am just considering only magnitude. Now write down the magnitude of Z1 and the magnitude of Z2, because phase angle is not required. I have already told you net current will become zero only. It could be possible only when two impedances are, see, I have proved everything. Either the impedance are equal or the admittance are equal or currents are equal. All are same only. All the relations are same only. So Z1 can be written as 1 by 3 times of omega C. Z2 can be written as omega into L. From this I can say the value of inductance C can be written as 1 upon 3 times of omega square into L. Okay, yes sir. So let us continue with this. They had given the information about inductance, right? 1 minute, let us go ahead back. 10 millihenry, it is already given. And what about the frequency? 50 hertz. Everything is given. Let us replace. Omega can be written as 2 pi into 50 whole square into the value of the inductance will become. What is the value of inductance? Inductance will be 10 millihenry. Okay, 10 milli means 10 into 10 power minus 3. Now reduce this, you will coming up with the value of capacitor. Right, if you want to let me reduce, I can do, that's not a big deal. 2 square will be 4 into pi square into 50 square will be 2500 into 110 into 10 power minus 3. See, 110. It will be 10 power 3. 10 power 3 into 10 power minus 3 will be cancelled. So finally it will become 12 pi square. Just to calculate this value. Wonder what? 12 pi square if you estimate, that will give you the value, approximate value of the capacitor. So I just wanted to know the value of 12 into, so that will give you the value of uh, 1 minute. I just wanted to see. I'm getting 0.0084. Any mistake here? Answer is not given. I'm just substituting 0.0084 farad, or we can write this one as 8.4 millifarad. So that is the value of the capacitor. Okay, I hope you all have understand this. So this is how we are estimating the value of what I can say. See, here doesn't matter, these calculations that are not important, but you must understand this basic, because I have been observing these type of questions are many times getting repeated in many exams. But it is very important to observe these basics when two branches are connected in parallel, or whether we are considering two branches or three branches, it doesn't matter. While considering the branches, it is very important to know the relations, how to bring these two values. Okay, then only you will be able to bring out the answer in a easiest way. Okay, chalo. So let us go ahead with the next question. So this is the given question. Next one, let me consider this value. Network. The given network is, they told that for the balanced star to star, this is star, this is also in star, star to star connected three-phase circuit shown in the figure below. The line to line voltage is, they told that the line to line voltage is given as 208 volt, and the total power absorbed by the load is given. Total real power absorbed by the load. Complete load is absorbing the real power of 432 watts. Now the question is, power factor offered by the network also given as power factor is zero point 0.6 leading. They told that power factor offered by the network is 0.6 leading. Now the question is, the approximate value of the impedance is that is dash. Then what is the this impedance? They told is that now this value is what? Per phase impedance only. They mentioned that this impedance is per branch value is considered as Z. So they are asking per phase impedance only. Z is dash. That's all. That is the given question. Now take your own time and try to bring the answer. Okay, I'm giving this question as the homework question to you, because you have to learn the subject in a proper way. If I'm dropping everything here, then you may not be able to understand the question in a proper way. So you can consider this whole question as the homework question. Spend your time slowly, just apply all the basics that you have learned, such that you will be coming up with the answer. Okay. uh, Rajesh, star to delta conversion is C by 3. Arey, again I am doing the same mistake. Where is that? I did the calculation. Where is that? Star. I did the correct sequence only now when we are going from star to delta. How it is become C3? So we are going from star to delta only. So this is 3C, this is C, this is also C, right? So when we are going up with the delta connected system will be equal to 3 times of star connected system. Okay, see, Sorry guys, actually we are with the capacitor. It's really very beautiful question. Yeah. See, do you remember there is one process? Thank you, Rajesh. Guys, listen. I forgot to deliver this. When we are having a resistor, we can say while going from star to delta, resultant value will become 3 times of R. If I'm going from, if all the values are equal, while going from star to delta, it will be 3 times of R. Similarly, if you have the inductance, if you are going from star to delta, it will become 3 times of L. If you have capacitor, it will be what? It will be C by 3. Why sir? Because we know the capacitor property is opposite to these two property. While writing the inductive reactance, you will be writing j omega L. But while writing the capacitive reactance, we will be writing 1 by j omega C. See, they are reciprocal to each other. If you have 3L, it will be C by 3. The capacitor value will be divided by 3 times. I forget this to say. I'm really sorry. So take this value just to do some small modification. What will happen? Nothing will happen. In place of 3 times of C, it will become C by 3, such that 3 will appear in the numerator. Our conversion formula is correct only, but the mistake I have done is with the capacitor. So just be careful. Bring this 3 numerator to the numerator, it will become 3 by 4. If it is 3 by 4, then what will be the answer? 3 by 4 means 0.75, right? So let me do it. Sorry. So when I'm bringing this value to the numerator, it will become 1 minute. So the value of capacitor value. So I'm just equating these two. From this I can say the value of capacitor C is equal to 3 upon omega square into L. Now you can substitute all the values to bring the answer. 3 upon 2 pi square, 2 pi f, right? So it will be 2 pi into f whole square into the value of inductance is 10 millihenry. You can do it, right? You can do it by yourself. Drop the answer. I don't want to waste my time. But don't forget the conversation, this conversion. I actually forget this. So we are in capacitor actually, right? So it should be C by 3. Okay. Now take this question next. As I already told you that you can take it as a homework question. This because it is very important to understand the basics by yourself, right? Okay, sir. So there are so many questions apart from that. I will try to solve all questions in the upcoming lectures one by one. And apart from that, we will be also having some interview sessions now. So in that interview sessions, I will be three-phase circuits also. There are so many interview questions in this three-phase circuit. So before bringing those questions in front of you, I'm just requesting you to go through all the basics, whatever that I have delivered so far. See, there is no anything left so far. We have solved a very less number of problems, but I have covered almost all basics that are required for the three-phase network. Now you know how to calculate the three-phase real power, reactive power for per phase and for the source, and you also know how to calculate the power factor for the three-phase load. I have individually calculated the real power, reactive power, everything we have done. Star connection, delta connection, conversion. So I have covered almost all type of models. Anyway, let me bring you a few more questions also in the upcoming sessions. Three phase is little bit important. If I spend lengthy time here, it may be affect you. So first understand and understand the subject slowly. At the same time, try to solve the questions by yourself also. Find a few more questions, try to bring find there are so many three-phase circuits questions are available in the internet. You can also try to solve with the help of the basic three-phase questions that I am solving here. Try to solve some questions which are related to the electrical machines and power system, such that whatever the doubts that you are having, do one thing, solve only balanced networks. If you are having the knowledge of unbalanced network, you may proceed further. If you are having no sir, I mean fundamental basics only, if you are feeling like that, in that case you may spend some time to understand the basics difference between balanced network and unbalanced network, then you may proceed further. Okay, so this is all for this lecture. Remaining things we will see in the next class. Thank you all.